Hello all, welcome to 100bytes.com. In this video, we will explore about the Lambda expression from the Java. The Lambda expression is an important feature from Java since 1.8 to support a functional programming. As we know that Java is a pure object-oriented language and it forces us to create a class even for a single function which can be used only once, and there is no way to pass a function as a parameter to another function, or it cannot be assigned to a variable and it get used elsewhere like how we use the function in a JavaScript. These are the important features which are missing in a more civilized language like a Java. So Java has come up with a new feature called a Lambda expression to support the functional programming. So let me read out the definition from the Oracle website. A Lambda expression can be used to implement a functional interface without creating a class or an anonymous class. Lambda expressions can be used only with interface that declare a single method. Let me go point by point here. So Lambda expression can be used to implement a functional interface. What is functional interface? A functional interface is an interface which has only one method in it. We already have a functional interface from the past, that is like a runnable is a very famous functional interface which has only one method called a run. So this Lambda expressions can be implemented without creating a class or anonymous class. Yes, like till now, even for this functional interface, that is runnable interface, to implement a run method, we need to create an anonymous class. But with the help of lambda expression, we no need to create an anonymous class. Let's go to the third point. Lambda versus anonymous class. Does this lambda expression is going to replace the anonymous class? Short answer is no, but the long answer I'm going to explain it. As a lambda is a stateless, where anonymous class is stateful. As you know that class always have a state, so anonymous class maintains a state, whereas a lambda expression is an expression, it's a simple expression which does not maintain any state. Anonymous classes introduce new scopes where lambda works in the same scope of an enclosing class. That means like an enclosing if a variable is defined in an enclosing class, and an anonymous class can allow you to define the same variable. The variable with the same name. But with the lambda, it is not like that, because it's not going to introduce a new scope. It's going to work with the same scope of an enclosing class. And as we know that anonymous class will compile into a new subclass, you will see a dot class file, but with lambda expression it is not like that. And lambda can be used only with a functional interface. That means like the interfaces with more than one functions, which can be where lambda expressions can't be used, but only anonymous class can be used, or anonymous class or normal other concrete class can be used. Lambda expressions removes the use of boilerplate code. I'll explain you in the later part in my demo. Lambda expressions can be passed as a parameter to another functions. This explains that lambda expression can't replace the anonymous class fully, but this lambda expressions comes in handy in many places where we want to create a throwaway functions. Let's get into the development. I'm using the Eclipse IDE to show the demo in this tutorial. I'm using the latest Eclipse, that is March 1. Suppose if you are using in Kepler, you have to apply a patch which is described in this link. Or better, you can get the latest Eclipse. In addition to that, you need to install the JDK 1.8. Okay. So this starts with a demo from the 6th point onwards. So this will explains like in this lambda expressions what are the types we can able to define. That is without parameter, single parameter with single statement, more than one parameter, more than one statement, lambda expression as an object with non-primitive data type, accessing a local variable by the lambda expression. Here I have defined a functional interfaces, like these are the functional interfaces. I'll explain you how it relates with the function with the lambda expressions. So let's assume like this is defined, this is annotated with the functional interface. If I try to add another function, let's say int operation 1, then this will throw an error like a functional interface. I mean, it is not a functional interface because the functional interface will have only one function to be defined. So I'm removing that. Okay, let's get into this one. Actually, this is the actual lambda expression. Okay, so this part forms as a parameter part, and this part forms a statement part. So as like think about this as a normal function where the parameters are passed in this, the parameters are defined, that is actually formal parameters are defined here, and the actual statements which is inside a function will be defined in this, I mean right side of an arrow. Okay, I'm calling the print banner with this lambda expression. Let's go to the print banner. So this print banner is defined with a no parameter interface. That means like if you see in the no parameter interface, just it has a only print banner. Is only the method defined with the print banner, and there is no types and it is not returning anything, and there is no parameters passing. This function is passed as a parameter, that is to the print banner. Okay, and in the print ban and in this is received at the function, and it calls that method. This will actually execute this lambda expression. This is how we have to define it for the 0 parameter. I will show the output of this after explaining all the types of lambda expressions. And the next is a single parameter with a single statement which returns a value without a return statements. That means like this, if there is only one parameter, this optional one, you can ignore the parenthesis, and if there is only one statement, you can ignore the return statement. That is like if there is only one statement is there, and lambda expression has a feature to return that value. So here this square it, that means like whatever the value which passes to this square, it will square the value, it will return the square of it. So I'm calling let me go to the square it method. So this has a the square it method is receiving a single param interface. Okay, let's see the single param interface definition, which has one square it method which takes one parameter and returns an integer value. This part of this lambda expression which is get assigned, that means like which is get assigned to the single param number, and this number it gets calling the square it, and actual value is passed in this whenever you are calling. So here it's only a definition. Here the lambda expression is just a definition. We are not passing any values here. This actual value is passed whenever you are calling that function. Similarly, if there is more than one parameter is passed, then a parenthesis is needed. So that is what I explained here actually. Okay, and the next one is like if there is more than one statements and you need a curly braces and return statement. So this is actually a part of a statement part in the lambda expression, and it has a more than one statement. So we need a return keyword to return the value. And the next is an object. That means like we can assign this value. We can assign this lambda expression to a reference, and that reference can be used elsewhere. That means here it get used there, and we are calling this math operation function. What is math operation function? Is it has an operation which takes an integer, two integer objects, and one it returns an int. Till now we have seen on the primitive type. Let's see the how we can use the non-primitive type in the lambda expression. Before that, I want to show one more thing. Like there is one class I have defined as an employee class which has a number and name. It's a very simple class which will takes a number and name. Okay, and there is an interface called employees. It is a functional interface which will takes an employee as an object. Let's get into this lambda expression. So in the lambda expression, we have an EMP as a parameter is passed, and there is in the statement we are trying to print the number and the name of that employee object. Okay, and in the non-primitive type you see here, so it takes an employee object, employees interface as a reference, and it creates the employee object and it processes it. Okay, so let me move that mouse over this EMP. So you see here this EMP is defined as an employee. This EMP is identified as an employee data type. You wonder like how we haven't defined anything we haven't defined anything EMP as an employee, but how it get identified. This is called type inference. Java uses this type inferences to identify the type of a parameter. Like how it means, like first the compiler first it will go to the non-primitive function where this is defined as employees. Okay, from this it will identify this is a type of an interface, and from the type of the interface it will go to that interface and it identifies the type of an object. So this is the one which was shown in the tooltip when I mouse over this EMP object, EMP parameter. So if you see here, let me move over again. So here you see here it is an employee, not an employees. Okay, and the next is we will see the scope. I have explained earlier, like this lambda expressions did not define any new scope. It uses an enclosing scope. So here here actually I'm accessing a local variable which is defined in the enclosing class, and let me try to define that. Let me try to define the same variable again. Let's see what happens. So there is a compilation error. You see here, like its local variable cannot redeclare another local variable. So that means it is using the same scope, same enclosing scope of that means lambda expression uses the enclosing same scope of an enclosing class. So let's run this program. Let's see the output. Okay, this is what it ran and it came up. So here the single this is with a no parameter. Okay, 0 parameter 1. These two statements are printed for the demo of more than one statement and more than one statements, and the next is lambda as an object, lambda expression, and last before one is like lambda expression as a non-primitive object, and finally again the 0 parameter, but it is accessing a local variable. We will see the remaining demo in the next video. Thanks for watching it.